Okay, now in this lecture we will see the other image parameter, that is fourth one, which is image transfer constant. So here we'll see what it is and how it is defined and how to derive it. So as per this, when a two-port network is terminated with an image impedance and excited by a source EG as shown in the figure, then theta I is considered as image transfer constant, where exponential to the theta I is equal to under root E1 I1 by E2 I2. So that means the image transfer constant is defined in this manner through this expression, right? So here what is the square root of E1 I1? E1 I1 is nothing but input power, E2 I2 is nothing but output power, and it is given that the network should be terminated by image impedance, and if it is considered as Zi2 here, it will be Zi1, which is impedance seen from the port 1 is nothing but Zi1, right? So what is this E1 here? E1 is I1 into Zi1, E2 is I2 into Zi2, and if you replace this E1 with I1 Zi1 here and E2 with I2 Zi2, you will get e power theta I is equal to I1 by I2 into square root of Zi1 by Zi2. Fine. Okay. Now we will get the image transfer constant for T network. So the network we are going to replace it with T, right? And we have input impedance of Zi1 and terminated impedance of Zi2. So for this, first we have to get I1 by I2 ratio. Then anyways we are having Zi1 by Zi2. So with that we will get e power theta I. So from e power theta I, how to get theta I? You just need to apply natural logarithm on both sides. Fine. So first we will get I1 by I2 ratio. For that you apply loop equation here in loop 2, that is KVL. So with that you will get I1 by I2 ratio. Fine. All of you try to get it. So it is a very big derivation. We cannot go through all the steps involved. So you have to practice this. Right, now at port 1 we will see now. So at port 1 we have ZOC1, right, and we have ZSC1. Fine. So how to get ZOC1 and ZSC1? Otherwise Z1OCR, Z1SC. So you need to open circuit the other port and then get the input impedance. Similarly, you need to short circuit the other port and get the input impedance. The same things can be performed at port 2. Then you will get Z2OC and Z2SC. Fine. So now we will square this e power theta I on both sides. So what do you get? It will be e power 2 theta I, which will be equal to I1 by I2 whole square into Zi1 by Zi2. That means I would like to eliminate this square root here, right? So with that what will I get? Okay, let us keep this aside like this expression, you keep it aside. Fine. Now we will do some manipulation based on open circuit and short circuit impedances. So first one is Z2OC minus Z2SC, so which will be giving you this one, right? So from this we will do one more manipulation, that is ZOC1 into ZOC2 minus ZSC2. So with this you will get Z3 square. Now I will replace this Z3 square with this one. Fine. So when you do that, what do you get? Z3 will be equal to square root of Z1OC into Z2OC minus Z2SC. Right. Now from 3, that means what is 3 here? So 3 is this one, Z2OC equals to Z2 plus Z3. So from 3 you have this one, this expression. Then from this we can get Z2 is equal to Z2OC minus Z3. Since we have already determined Z3 here, you can directly replace that here, so that you can get all Z2 and Z3 in terms of open circuit and short circuit impedances, right? Fine. Now we got Z2 and Z3. Now what is the ratio of I1 by I2? So if you consider I1 by I2 here, you will get it equal to the Z2OC plus ZI2 divided by square root of ZOC1 into Z2OC minus Z2SC, right? So this also you can verify, this you will get. Now that means here if you get this numerator and denominator, that will be equated to this one, Z2 plus Z3 plus ZI2 divided by Z3, right? Like that you can verify it. Fine. Now I am going to square it, right? So I1 by I2 whole square, if I do it, it will be like Z2OC plus ZI2 whole square divided by this under root will be cancelled. Now we already know that Zi1 and Zi2, which are in terms of open circuit and short circuit impedances. Okay, so now I will be considering this equation now, e power 2 theta I. So what is that? E power 2 theta I is equal to, so we have I1 by I2 whole square, so you get that from this I1 by I2 whole square and into Zi1 by Zi2, right? So now I will take two more products from open circuit and short circuit impedances, so you will understand why I am considering this. So first one is Z1OC into Z2SC and the other one is Z2OC into Z1SC, right? You get them and keep them aside. Fine. Okay, now if you, since these two are equal, if you divide these two, ratio under root, you will be getting equal to 1, and I am considering that as equation number 6. Okay, now you can simplify this in this manner. Okay, so that is e power 2 theta is equal to, I will take Z2OC square common here, then you will get this expression. So here again I will simplify that to this, right? You can practice this, all of you practice it with your pen and paper. And e power 2 theta is equal to, these two will be cancelled and I am taking this into inside, so with that manipulation I can get this. So now I am considering this as equation number 7, and you got this equation number 6 where this relationship is equal to 1. So I am directly using that here, I am directly using that in this equation so that I can simplify it further. So if you see, you will get this equation which is like e power 2 theta is equal to 1 plus square root of ZSC2 by ZOC2 divided by 1 minus square root of ZSC2 by ZOC2, right? Now if this is e power 2 theta I, now I would like to consider e power 2 theta I minus 1 by e power 2 theta I plus 1. So then that will be equal to Z2SC by Z2OC under root. Okay, now if I further simplify this, in the end I will be getting tan H theta is equal to square root of ZSC2 by ZOC2. So this is the final equation. See, we got very simplified equation, but the work that has gone through for getting this is very tough. See how big derivation is this, right? Okay, but the end result is very simple, and one thing you can note down here is that, so tan H theta is equal to square root of ZSC2 by ZOC2. That means the image transfer constant is completely depending on port 2 side parameters, right? There is no dependency on port 1, so that is very important here. With that you can remember it is very easily. Fine, then what is theta I? Theta I will be tan H inverse of under root Z2SC by Z2OC. Fine, this is what you will get in the end. That's it. Thank you.